Hello students, now today we are going to discuss the Graham's law of diffusion. Okay student. The spontaneous intermixing of gases to form a homogeneous is called the diffusion of gases. Okay, what is meaning of this line student? When you are mixing spontaneously the gases in a homogeneous manner, that is called diffusion of gases. Okay, next point, the spreading of the gases into space available to them is called the diffusion of the gases. Okay, so whether it's spreading, either you say, or the mixing of the two gases, you say, that is both are the same terms. The gravitational force of attraction have least influence on the diffusion phenomena. Means there is no gravitational forces on the diffusion rate. Diffusion of the gases is non-directional phenomena. Means diffusion can be in any direction, depending on the volume. Any direction it can be. The volume of the gas is diffused in unit time is called the rate of diffusion. Okay, that point is important point student. The volume of the gas that diffuse in unit time is called the rate of diffusion. For gas, R is equal to V by T. Okay, rate of diffusion is volume by time per unit. So rate of diffusion, volume of diffused, and time of diffusion. A gas having low density molecular weight is called the light gas. Okay, a gas having low density molecular weight is called light gas. Next, lighter gas diffuse quickly than the heavier gas. The rate of diffusion of gas is inversely proportional to the square root of density, comma, vapor density or molecular weight. Okay, this is all the three way we can define, that is vapor density, molecular weight. This is called the Graham's law of diffusion. Okay student, according to Graham's law of diffusion, first equation is rate is equal to inversely proportional of root of density. Rate is equal to inversely proportional root of vapor density, and rate is equal to inversely proportional to root of molecular weight. For two different gases diffusing under similar condition of the temperature pressure, R1 by R2 is equal to D2 by D1, or R1 by R2 is equal to VD2 by VD1, R1 by R2 is equal to M2 by M1. For two different gases diffusing under similar condition of temperature and pressure, so R1 by R2 is equal to B1 T1, B1 by T1 into T2 by V2, or R1 by R2 is equal to N1 by T1 into T2 by N1, or V1 W1 by W2 is equal to root of M1 by M2. This is the equation for the rate of diffusion. If two different gases at the same temperature but different pressure diffuse, so R1 by R2 is equal to P1 by P2 root of M2 by M1. So this is if the different gases of the same pressure but at different temperature diffuses, so R1 by R2 equal to root of T1 by T1 M2 by T2 M1. For gases in the same temperature and pressure, ratio of density is equal to ratio of molecular weight. So that is L1 by L2 is equal to root of M2 by M1 equal to N1 by N2. N1 and 2 are moles of the gas 1 and 2. L1 L2 are the length traveled by gas in gas 1 and gas 2. Okay, so this is all about the Graham's law of diffusion student. In the next video we will try to solve out the problem based on it. Thank you so much for watching friends.